Hi, this is Orkoprabhu Dondi. As a part of NAAI Data Science Internship Program, so I am streaming my uh, Project 8, and the topic of the Project 8 is Machine Learning for Predictive Analysis. So, as a part of this project, my first objective, or actually the project is I have to reduce the monthly churn by identifying high risk customers well in advance. So, to implement this project, the I have to perform certain objectives. So, my first objective is to perform initial data preparation, and under that there are A, B, C, and three tasks. So I will show you the first task one by one. So here I have imported some of the important libraries in of the Python, and here I am uploaded the dataset in my Google Drive, and from that drive I am reading the entire dataset, the first dataset, which is telecom, and it is stored in cast underscore df variable. So it is my current dataset's name, cust underscore df. So I am displaying the shape of this data frame, and there are 51047 rows and 58 columns, and here I am displaying the size of the data frame by using the dot size function in Python, and it comes out to be multiplication of number of rows into columns. So it is 2960726, and now here I am describing the entire data set by using the dot info function in Python. It is giving me the data type of each of the columns in the data set. So what are the columns, whether it is an integer, whether it is an object type or float. Now here the first objective is I have to detect and find how many customers are having monthly revenue equal to 0. So from this data set I have taken the column monthly revenue, and there I have to find how many number of customers are having monthly revenue equal to 0. So it is coming out that there are 6 customers, as you can find that there are 6 rows, 1 2 3 4 5 6. So there are 6 customers with monthly revenue 0. Now I am excluding the number of customers who are having monthly revenue 0. So I am considering the data set, or considering the column of the data set monthly revenue where the customers monthly revenue is not equal to 0. Now I have to find out how many columns have missing values of percentage greater than 5%. So for that reason I have taken a variable percent underscore missing, and here dot is null function calculates the each of the null values present in each column, and which is divided by the length of the column into 100. So I can find in each column how many there are missing values. So it can be find that there are 0.3, 0.7%, and up to 1.7%. So there are no missing values which are greater than 5%. I can find. So that is stated, no columns are having missing values more than 5%. Now I am dropping the columns. Now I am by using the drop now function in Python. I am dropping the rows from the dataset which are having null values. So after dropping the rows of the null values, the size of the dataset is reduced, and now the number of rows results to 49748, and columns remains the same because we are deleting the rows. Now I have to remove the outliers in unique subs and direct assisted calls column. So here in the calls I have created a list named cols columns, and there I have taken two names of the two columns. One is unique subs and direct director assisted calls. Now I have box plotted on these two columns, and from this box plot I have found that there are some outliers present, and from these outliers I have to identify top 1% outliers. So for that reason I have top 1% outlier, means that has to be of 99 percentile or 99% quantile. So here uh, I have taken the values in the dataset which are having in the unique subs the maximum value is 5, so it will be the maximum top 1% outlier, and in director assisted calls the top 1% value is 9.65. So I have to take the values of the columns in which the values in unique subs are less than or equal to 5, and the values in director assisted calls I have to take the values which are less than equal to 9.65. So ultimately the top 1% outliers are removed from these two columns in the dataset. Now here I am performing some exploratory analysis in the dataset. Now I have to find a relation between the monthly revenue and the overage minutes. So by using this scattered plot I can find that with the increase in monthly revenue the overage minutes are increasing. So it is found that the correlation between monthly revenue and overage minutes is 0.78, which is close to positive 1, and since it is a positive correlation, so they are more monthly revenue and overage minutes are positively correlated. Now I have to find, does high number of active subscribers leads to low monthly revenue? I have to find. So for that reason, because our second objective is to be, does high number of active subscribers lead to monthly revenue or not? So for that reason I have taken active subs column, and since active subs is a categorical column, so I have to find out in how many there are categories, and under each category how many there are distinct rows. How many distinct rows means there are distinct, how many there are distinct customers under each category present in active subs column. So I can find that there are 6 categories, and under each category the number of rows or number of customers, which is given by value underscore counts function in Python. Now I have plotted in the x-axis I have taken active subs, and monthly revenue has been taken in y-axis, and I have taken a categorical plot. So from the categorical plot we can find when the subscriber has when the subscriber is under the category 1, they have larger monthly revenue, and as we increase, as the x value increases, that is the active subs value increases, that is the number of active subs increases, we can find from this graph that 1 2 3 4 5, from 1 to 2 to 3 to 4 to 5, as the x value increases the monthly revenue decreases. Now I have to find, does the credit rating have an impact in churn rate? So for that reason, churn rate means that it is a categorical column again, and so there are two values, that is either will be yes or no. So for that reason we have taken the churn in the hue, so we can find how many are yes or how many are no, and I have taken in the x-axis the credit rating, and credit rating is also again a categorical column, and there are 1 2 3 4 5 6 7 categories, and I have in the in the y-axis the number of values in each category are taken or plotted. So basically under each category, under each of the 7 categories, I have found that how many number of people belonging to each class are either churning or not churning. So you can find that customers falling under the high credit rating, they are they have the maximum probability of not churning, and they are also recorded the maximum who are also churning. And from this plot we can find that this orange graph displays that the people who are not churning. So under each categories we can find that maximum people turned out to be not churning. So I have also created additional features because our third objective was to create additional features to help predict churning, or to help the model to predict churn. So therefore there are ABC three objectives. So first objective was percentage of current active subs over total subs. So similarly, I created a function which is called a wrapper function, and it takes the dataset as its input argument, and I have taken customer underscore df, and I have created a new column named percentage active subs, and here I have taken the value of customer df active subs, which is divided by total number of unique subscribers. So I will get a fraction, and basically this is kind of and this is multiplied, this is a kind of fraction, and which I get in active subs data column. In the same way I have calculated percentage recurrent charge. Here sorry here I have taken total recurring charge as the numerator, and monthly recharge as the denominator. Similarly, I have created a column named percentage overage minutes, and here I have taken overage minutes in the numerator and monthly minutes in the denominator. And in this way I can find the percentage overage minutes and percentage recurrent charge. All will be created, all these values will be, all these three new columns are created in this data frame, and I am returning the newly created data set. So basically all these values, each of the values are multiplied with 100. Now I am make a call to the feature engineering wrapper function, and here I am making the call through this function where I have taken my data set as the input argument, and our new data say my new data frame is created, which is stored in the cast underscore df, again variable. And from that variable, since we have since here is a division is occur, so maybe there are sometimes some values, sometimes we can get values that are division by 0, which is not division by 0 is not we it is replaced with null value, or division by 0 is not possible, we always get that. So for that reason we have to check for the missing values, so that helps us with the isNa function. So isNa function is that which checks the missing values in each of the columns, and here I am in each of the columns I am checking how many there are missing values, and that the total number of missing values is then done by using the sum function in Python. And here I printed how many there are missing values. So it can be found that in percentage overage minutes, since there is a division is done, so there are 667 missing values. So where there are missing values, I am the rows x is equal to 0 means the rows in which the missing values are found, I am filling with the values 0, and in place equal to true means where there are missing values, I am filling these missing values with 0. Right now, after that I am separating the categorical and continuous columns. So by using the categorical columns variable, I am creating a list where I am selecting the data types which are kind of object data types, and all their column values are put into the categorical columns. In the similar way, the continuous columns are uh, also put in this list by using the by only selecting the columns which are having data type of number. So after that, in the categorical columns where all the categorical columns of the dataset are taken, and in the continuous columns, the columns where the values are of number data type are taken. Now, from the categorical column, I will have to take those categorical columns which are not present in this list: churn, customer ID, service area. Now why I am doing this? Because churn will be our target variable, and so it should not be present in the feature data set of the model. So it has to be present in this churn column, has to be present in the target data set of the model. And customer ID and service area, these are unnecessary columns. So I have taken these three columns headings together, and I have to take those categorical columns in the feature dataset which are which are not churn or customer ID or service area. And after that, from the continuous columns, I am also removing the customer ID, since it is also a new integer or numerical data. After that, I am implementing a function named categorical important, check underscore categorical important, where I have taken dataset as the input and categorical columns as the input. So by using the chi-square function, it is returning those categorical columns which are important for our model's predictive analysis. Now I am checking in the target variable, that is churn is our target variable, and from that churn's target variable I have to find how many number of data points are present in each class. So here class is yes or no. So it is found that there are 71% of the dataset, or 71% dataset belongs to no class, and only 20% of the dataset belongs to yes class. So it can be found that usually it is a imbalanced type of class dataset, because they are not equal, not balanced. So to make it a balance, so we are following oversampling process. So oversampling process is what? It is basically I am making the yes class same as that of the no class. So here it is 28% and here it is 71%. So here in the yes class we are adding 71 minus 20, that is extra 53% of the 53, sorry, it's 43% of the extra dataset is added in the yes class. So that is done by using the oversampling method here, where the class 1 underscore over is oversampled, and in this way I am doing this. So class 1 corresponds to the yes column and class 0 corresponds to the no column. So after balancing the dataset, it is found that class 1 has 50% and class 0 has 50%. So this is the code to oversample the class 1 dataset. Class 1 is class 1 target variable of the dataset, right? Now I am building a classification model, because we have to, in our objective, our aim is to build two classification model to predict customer churn. First of all, we have to build a simple logistic regression model, then I will build a random forest classifier model, right? Now from scalar model.selection we have imported train test split method, and but in the x-axis I have taken the important categorical columns by calling the function and those continuous columns, and in the y value I have taken only the churn column. And why I am using the get underscore dummies function? Because in the categorical columns which are taken in the features dataset, they are kind of sometimes they have the values yes, no or unknown. In that case those values will replace by 0, 1, 2. So for that reason we are using the get underscore dummies function, which is usually available in the pandas module of Python. Now I am using train underscore test split function on the x and y to split it into train and test dataset. I am also using standard scalar function from the pre-processing library of sklearn, Basically, why I'm using standard scalar function, because in x underscore train and x underscore test dataset, both in the x underscore train dataset, both the columns will have same values and they will be of same range. So for that reason, it will be easier for the model to predict the result, because if the results in the columns have higher variance, so it will be difficult for the model to train on that data. So for that reason, we are scaling each of the columns of the training dataset as well as on the test dataset by calling the standard scalar function in Python. Now I am importing the logistic regression model and all the kind of metrics that will be used to evaluate our logistic regression model uh, on this dataset. So here I am, after fitting the training dataset, here I am predicting the dataset, because we are using the predict underscore probability to predict the classes of this dataset. So basically probability is used because it will be because actually since we are treating with real values, so it will be easier not to fall into the data into the directly into class 0 or class 1, because sometimes they have a slighter or some some more or a good chance of falling into class 1 or class 0. So for that reason we are using predict underscore probability function. And yes, for ROC curve plot, we are using FPR, TPR thresholds, this variable on Y test and Y prediction, where false positive rates, TPR and threshold values are stored. Now I am creating a accuracy list where the best accuracy corresponding to the best threshold values will be stored. So we are displaying here the thresholds corresponding to the accuracy of the logistic regression model. Now here I am again using this model to predict on the test dataset, and after all I am using the probability threshold to classify the customers is either 1 means it is churning or 0 means it is non-churning. So I am using the base threshold values on the test dataset by the model to predict whether the customers are churning or not churning. And after that I am printing a classification report on Y test and Y prediction dataset, and here I am getting a classification report how the model is performing on the test dataset. So the model's precision is 0.58 to predict the customer is not churning, and 0.59 to predict that customer is churning. And here I am printing the confusion matrix of the logistic regression model, and here the accuracy comes out to 0.5874. Now here the ROC curve for logistic regression model is plotted, and APR is taken on the x-axis and true positive rate is taken on y-axis. Now similarly a random forest classifier model is built here, and similarly in the same way as that of a logistic regression model, we have performed the model on the test dataset, and it is seen that logistic regression model's accuracy is 0.899, which is far more better than that of logistic regression model, which was scoring 0.58, right? After that I am identifying the most important features that help me in predicting the impacting on the churn rate. So I have taken a top 20 underscore features variable, and by using the pandas.series function, by using the random forest, since random forest is performing great, so I have taken the random forest model which during that predicting case which had taken the important features, and I have taken those features which are of top 20 important features which are taken by the random forest model to help in prediction of the customers of churning or not churning. Now I have plotted those top 20 important features in ascending order, and here it is plotted by taking ascending equal to true, right? So here this is my code, and thank you.